Hi Year 9, you're starting a new topic today. This week's topic is about the Earth's structure. The Earth is made of three distinct layers. There's the crust, which is the outer layer, which is made of solid rock. There's the mantle, which is semi-liquid rock or magma underneath the crust. And then there's the core, which is the centre of the Earth, which is made of nickel and iron. The crust is very, very thin. To give you an idea, it's the same size as a sheet of paper would be if the Earth was the size of a basketball. The Earth's crust is broken up into a series of chunks or slabs. These slabs are named after the part of the world where they occur. And if you look at the map carefully, you should be able to see that the UK lies on the Eurasian plate. There's also an African plate, a North American plate, an Australian plate, an Indian plate, and so on. And these tectonic plates, or these pieces of the crust, float around and move very, very slowly. This map shows where earthquakes and volcanoes occur in the world, and you should be able to see that there's a pattern. Earthquakes and volcanoes occur in the same places, and they occur in what we call long narrow belts or long narrow lines. And if you go back to the previous slide, you should be able to see that this location matches the plate boundaries or the edge of the plates where two tectonic plates meet. I've marked on the map where the UK is. We don't get earthquakes and volcanoes because we are in the middle of a plate. I've also marked on the map the Pacific Ocean, which has a nickname of the Ring of Fire, because all the way around the Pacific Ocean there are volcanoes, hence the name Ring of Fire. These tectonic plates, or these part of the crust, can actually be split into two different types. There's continental crust, which is basically land crust, which is lighter and permanent. And then there's oceanic crust, or the crust underneath the sea. This is continually being destroyed and created in places and is actually heavier than continental crust. The tectonic plates actually move very, very slowly. And they move because there's heat circulating in the mantle. And if you can look at the diagram, this circulation of heat, or this heat going round and round and round, is called a convection current. And these convection currents either make the plates move apart or towards each other. And this is going to be explained over the next few slides. There are four scenarios that can occur when tectonic plates move. On this page shows the four different types, and it's really, really important that for you to get a good GCSE mark, you must be able to know the difference between each one. I would suggest you watch the next 4 slides at least twice so that you can learn the different types of plate boundary. The first scenario is when two tectonic plates move away from each other. Remember, this is caused by convection currents in the mantle, and as the tectonic plates move apart, a gap is created and magma can come out that gap, which then becomes lava and creates volcanoes. You also get small earthquakes here. To get a higher mark, it'd be really good if you could tell me a famous place, and this scenario happens at a place called Iceland. The second scenario is a destructive plate margin or plate boundary. Here, an oceanic plate and a continental plate meet, and the heavier oceanic plate is forced downwards into the Earth in a process called subduction. As this plate gets pushed downwards into the Earth, it melts, releasing magma, which then can form a volcano. You also get earthquakes here, and a famous place in the world would be Japan. That's where subduction happens, where you've got a tectonic plate being pushed below another. The third scenario is when two tectonic plates try and move past each other or slide past each other. The edges of the tectonic plates are not smooth and therefore they stick together, pressure builds up, and eventually the tectonic plates snap free to create earthquakes. A famous location where you'd find this is the San Andreas Fault, and the city that lies on that is San Francisco. The final scenario is a collision plate boundary. This is where two continental plates come towards each other, and as they meet, the land gets pushed upwards to form high mountains. A famous place where this happens is the Himalayas, and the Himalayan mountains are actually getting higher every year. However, at the same time, some of the top of the mountain, such as Mount Everest, snaps off, so overall they stay about the same height every year. Before you have a go at the quiz this week, I would watch the video at least once more through. You might want to make a few notes on the different plate boundaries. Once you've done that, go to joinmyquiz.com and put in the number that will be shown next to this video on the Carmanner e-learning page. It'll be just above it. Good luck everyone. It's a really important part of the course this, and I hope therefore you get a good mark in the quiz. Bye now.